Hello everyone, welcome to University Academy YouTube channel. So we are doing network analysis and synthesis subject and आज के lecture में हम लोग देखेंगे transient response के questions. Okay, so let us start with the question number 1. And उससे पहले अगर आपको इस topic की handwritten notes चाहिए, so link is given in the description box. You can download from there. Okay, so let us start with the question number 1. In the figure, the switch was closed for a long time before opening at t is equal to 0. So it means this switch was closed initially and at t is equal to 0 it is becoming open. Okay, so it means t is equal to 0 पे switch open हो रहा है, उससे पहले it was closed for a long time. So here long time, this indicate that for the t less than 0 the circuit is under the steady state. Okay, so the circuit is under the steady state for the t less than 0. Now it is saying that we have to find out the voltage v of x at t is equal to 0 positive. Okay, so यहाँ पे क्या है कि हम एक particular instant, that is at t is equal to 0 positive पे we have to find out the value of this voltage v of x which is across this 20 ohm resistance. Okay, so सबसे पहले we will draw the circuit at t is equal to 0 negative. It means just before the switching operation. So switching operation is performed at t is equal to 0. So t is equal to 0 negative. It means for the less than 0 instant our switch is initially closed. Okay, now the switch is closed and the circuit will be under the steady state. Okay, the circuit is under the steady state. So if the circuit is under the steady state, so I have told you that under the steady state condition the inductor it will behave as short circuit. Okay, and if the capacitor is present in the circuit then it will behave as open circuit. Okay, so let us draw the circuit for t less than for t is equal to 0 negative. So यहाँ पे हमारे पास एक 20 ohm का resistance है. Okay, this is 20 ohm resistance. It is connected in parallel with a current source of value 2.5 ampere. Okay, now at t is equal to 0 negative this switch will be closed. Okay, and the circuit is under the steady state, so this inductor it will behave as a short circuit. Okay, and this is connected in parallel with the resistance. This is 20 ohm and this is also 20 ohm. Okay, and the voltage across 20 ohm it is given by plus minus v of x. Okay, now we have to find out the current flowing through this inductor. So this is inductor which is short circuited. Suppose the current flowing through the inductor is given by I of L. Okay, so now this current source is 2.5 ampere. Now this path is offering the low resistance path because it is short circuited. So this 2.5 ampere current it will flow in this path. Okay, because it is short circuited, so no current will flow through this path. Okay, because this path is offering low resistance. Okay, and current जो है वो always low resistance path को ही follow करता है. It means the current flowing through the inductor at t is equal to 0 negative, it will be equal to IL of 0 and it will also be equal to IL of 0 positive, because we know that inductor does not allow the sudden change in current. So t is equal to 0 negative पे जो current है, same current it will remain at t is equal to 0 positive and the value of the current is given by 2.5 ampere. Okay, now we have to find out the voltage v of x at t is equal to 0 positive. So जब भी क्या है at लिखा है क्वेश्चन में, it means we have to find out the voltage at a particular instant. So in order to find out the voltage at particular instant, the inductor it will be replaced by the current source. Okay, so जो inductor होगा circuit में that will be replaced by current source and उसकी जो value होगी that will be equal to IL of 0 positive. and अगर circuit में capacitor होता then it will be replaced by voltage source, because we know that capacitor it will not allow the sudden change in voltage. So t is equal to 0 negative पे जो voltage था, same voltage it will remain at t is equal to 0 positive and जो polarity है that will also remain the same. Okay, but यहाँ पे क्या है, we have only the inductor. So now at t is equal to 0 positive this inductor it will be replaced by the current source जिसकी value होगी 2.5 ampere and its direction will be in this direction. Okay, so let us draw the circuit. So here we are having, and also at t is equal to 0 positive, so it is after t is equal to 0, so at this instant our switch it will become open. Okay, so let us draw the circuit. Here we are having a 20 ohm resistance. Okay, so this is 20 ohm. It is connected in parallel with a current source of value 2.5 ampere. Okay, now t is equal to 0 पॉजिटिव पे क्या है कि हमारा स्विच ओपन हो जाएगा. नाउ दिस इंडक्टर इट विल बी रिप्लेस्ड बाय करंट सोर्स. ओके, एंड करंट सोर्स की जो डायरेक्शन है वो प्रीवियस डायरेक्शन में ही रहेगा जिस डायरेक्शन में इंडक्टर के थ्रू करंट फ्लो कर रहा था, बिकॉज इंडक्टर विल नॉट अलाउ द सडन चेंज इन करंट. So the value of this current source is given by 2.5 ampere, and this is connected in parallel with the resistance, and the value of this resistance is 20 ohm, and the voltage value is given. This is plus and minus v of x. This is already given in the question. Now as this path is open, so no current will flow, so this 2.5 ampere it will flow in this path. Okay, and now this 2.5 ampere it will flow in this path. So इट मीन्स ये जो करंट है इस टर्मिनल पे एंटर कर रहा है, सो दिस विल बी पॉजिटिव एंड इट विल बी नेगेटिव. ओके, लेकिन जो वी ऑफ एक्स की पोलैरिटी क्वेश्चन में गिवन है इट इज़ प्लस एंड माइनस. सो फ्रॉम हेयर वी आर गेटिंग वी ऑफ एक्स इट विल बी इक्वल टू माइनस, बिकॉज इसकी जो पोलैरिटी है दैट इज अपोजिट एंड इट इज़ गिवन बाय आई इंटू आर. सो हाउ मच करंट इज फ्लोइंग, दैट इज 2.5 एम्पियर एंड द वैल्यू ऑफ रेसिस्टेंस इज 20 ओम. Okay, so if we simplify we are getting the v of x value as minus 50 volt. This is at t is equal to 0 positive instant. Okay, so answer is minus 50, that is option C is correct. Okay, now let us see question number 2. So question is, in the circuit shown below, the current excitation is, that is I in of t is given by 4 into u of minus t ampere. The IL of t for t greater than equal to 0 is, it means we have to find out the current flowing through the inductor. Okay, now input current given in the question is 4 into u of t. So the value of this current source is 4 into u of minus of t. So let us first draw the waveform of 4 into ut. So u of t is a unit step function. Okay, and it is 4 into u of t. Suppose, so यहाँ पे क्या है, u of t जो है वो एक राइट साइडेड है, its amplitude is 4. Okay, बट यहाँ पे क्या है कि जो इनपुट करंट सोर्स हमें गिवन है इट इज़ 4 into u of minus t. So this minus sign, this is indicating folding about y axis. Okay, इसी को बोलते हैं टाइम रिवर्सल. दिस इज फोल्डिंग अबाउट y axis. Okay, because यहाँ पे क्या है, t is replaced by minus t, so you have to fold about y axis. So let us draw the waveform for 4 into u of minus of t. तो यहाँ पे क्या है कि माइनस t है, इट मीन्स टाइम रिवर्स हो रहा है. सो इट्स वेव फॉर्म विल बी, सो यू हैव टू फोल्ड this waveform about y axis, so it will look like this. Okay, amplitude will remain same. So now 4 into u of minus t, it will extend from minus infinity to 0. तो यहाँ पे क्या है, t इज इक्वल टू 0 पे जो करंट सोर्स है उसकी वैल्यू इज चेंजिंग सडनली फ्रॉम 4 एम्पियर टू 0 एम्पियर. इट मीन्स एट t इज इक्वल टू 0 द ट्रांजिएंट्स विल अकर इन द सर्किट. ओके, सो लेट अस परफॉर्म फॉर t इज इक्वल टू 0 नेगेटिव. ओके, तो सबसे पहले आपको t इज इक्वल टू 0 नेगेटिव पे सर्किट ड्रॉ करना है. ओके, सो नाउ एट t इज इक्वल टू 0 नेगेटिव द सर्किट विल बी अंडर द स्टडी स्टेट. ओके, सो एज द सर्किट इज अंडर द स्टडी स्टेट, so this is network is consisting of inductor. So under the steady state inductor is replaced by short circuit. Okay, and for t is equal to 0 negative, it means just before t is equal to 0 the value of the current source it will be 4 ampere. Okay, so the value of this current source it will be equal to 4 ampere. Okay, it means t less than 0 के लिए current source की value कितनी है, 4 ampere, and for t greater than 0 the value of current source is 0. Okay, now this is connected in parallel with the resistance of, this is 400 ohm. Okay, and this is also 400 ohm. Now under the steady state inductor will become short circuit. Okay, and this is connected in parallel with the resistance, value is 200 ohm and this is 400 ohm. Okay, so the current flowing through the inductor, suppose it is I of L. So now we have to find out the value of this I of L. So let us find out the value of this current which is flowing through the inductor, that is I of L. Okay, so now this 200 ohm it is connected in parallel with this short. Okay, so now this 200 ohm, it will become insignificant because current जो है यहाँ से आएगा, it will flow through this path because इसका जो resistance है वो 0 ohm है. Okay, and current always follow the low resistance path. So current flowing through this 200 ohm, it will be 0 ampere, so it will become insignificant, or you can say dummy. Okay, so this is insignificant resistance. Now what is the value of IL of 0 negative? It will be equal to IL of 0 positive because inductor does not allow the sudden change in current. So यहाँ पे क्या है, both the resistance की जो value है वो equal है, so current will divide equally. So the current which is flowing through this path, it will go here, so it means this is I of L only. Okay, so the value of I of L we are getting as 2 ampere. Okay, now let us draw the circuit for the t greater than 0. Okay, so now for the t greater than 0, let us see. Now for the t greater than 0, the value of this current source, it will become 0. Okay, it means t greater than 0 के लिए what is the value of current source? 0. And if the value of current source is 0, it means, so for t greater than 0, input current source value is 0 ampere. So if the current source value is 0, then it will be replaced by open circuit. Okay, and let us draw the circuit. So it means current source, it will now become open. So now this is open, so we are having 400 ohm. Okay, so this is 400 ohm resistance, this is also 400 ohm. Okay, now here we are having the inductor, and the value of inductor given in the question is, so inductor value is 32 millihenry, which is connected in parallel with 200 ohm. Okay, so inductor value is 32 millihenry, and this is connected in parallel with 200 ohm resistance. Okay, the current which is flowing through this inductor is given by IL of t, and we have to find out this expression. Now this is source free RL circuit. Okay, as no source is present in this circuit for the t greater than 0, so this is source free RL circuit. So we have already seen the expression to find out the I of t current, which is given by I naught into e to the power minus t by tau. So I naught is the initial current flowing through the inductor for the t less than 0, which we have already calculated, and it is 2 ampere. That is I naught value we are getting as 2 ampere. Now next we have to find out time constant. So what is time constant? So this circuit is RL circuit, so यहाँ पे time constant is given by L by R, but here we are having the multiple resistances, then we have to find out R equivalent. Okay, so L value given in the question is 32 millihenry, that is 32 into 10 to the power minus 3. Let us find out the value of R equivalent. Okay, so R equivalent it will be calculated across. सबसे पहले क्या है, R equivalent calculate करने के लिए आपको circuit को deactivate करना है. So this circuit is not consisting of any source, so it means we don't have to do anything. Now यहाँ पे क्या है कि we have to find out R equivalent across this inductor terminal. So you have to open the inductor. Okay, so this is 400 ohm and this is also 400 ohm. Okay, so you have to find R equivalent across these inductor terminals. Okay, and this is 200 ohm resistance. So this is 200 ohm, and we have to find out R equivalent from here. Okay, so R equivalent we are getting as, so this 200 ohm resistance, it is connected in parallel with, so these two resistance are connected in series, so it will be equal to 800. So now R1 in connected parallel with R2, it is given by R1 R2, that is 200 into 800 divided by sum of both the resistances. So R equivalent from here we are getting, so it will be equal to 160 ohm. So R equivalent we have calculated. So substitute this value of R equivalent here. So R equivalent we have calculated as 160 ohm. So from here time constant we are getting, so this will be equal to 2 into 10 to the power minus 4 second. So substitute this value of tau, that is time constant, in this equation 1, then we are getting the value of I of t. So IL of t expression we have obtained as I naught e to the power minus t by tau. So I naught we have already calculated, that initial current flowing through the inductor we have calculated as 2 ampere. Okay, and time constant we have also calculated, so let us substitute the value. So I naught is 2 ampere into e to the power minus t by time constant we have calculated as 2 into 10 to the power minus 4 second. So it will be equal to 2 into 10 to the power minus 4. So let us simplify, so it will be equal to 2 into e to the power minus, it will be minus, it can be written as 10 into 1000 by 2 into t. So this will be equal to, so this is 2 into e to the power minus 5000 minus 5000 t. Okay, so this is in ampere. So this is the current expression passing through the inductor for the t greater than equal to 0. Okay, so this is the answer, that is 2 into e to the power minus 5000 t, matching with the option B. Okay, now let us see next question. So question is, in the circuit shown below, the voltage source 8 volt has been applied for a long time before the switch opens at t is equal to 0. It means initially the switch was closed, and here this long time is again indicating that the circuit is under the steady state for the t less than 0. Okay, now we have to find out the current IR at t is equal to 0 positive. So again we have to find out the current which is flowing through this resistance. So correction is there, so the value of this resistance is not 6 ohm, this is 6 kilo ohm. Okay, so make it correct, this is 6 kilo ohm. Okay, this is 6 kilo ohm resistance. Okay, so let me write here. So now we have to find out the current which is flowing through this resistance of 6 kilo ohm at t is equal to 0 positive instant. Okay, so सबसे पहले we will draw the circuit for t less than 0, that is at t is equal to 0 negative. So for the t less than 0, our switch was initially closed. Okay, so switch is initially closed and it is getting open at t is equal to 0. So switch is closed, so switch is closed and the circuit will be under the steady state. So now this circuit is consisting of capacitor. So under the steady state, the capacitor, it will become open circuit. Okay, so let us draw the circuit. So the circuit will become, so here we are having the 8 volt voltage source. Okay, and this resistance is 2 kilo ohm. Now at t is equal to 0 negative, this switch is initially closed. Okay, and under the steady state, this capacitor, it will become open circuit, and this resistance is 6 kilo ohm. So this is 6 kilo ohm. So let us find out the voltage across this capacitor. Okay, so the voltage across this capacitor, it will be given by Vc of 0 negative, because we are calculating at t is equal to 0 instant, and we know that capacitor does not allow the sudden change in voltage. So this will be equal to Vc of 0, and it will be also equal to Vc of 0 positive, because t is equal to 0 negative पे जो voltage होगी across the capacitor, same voltage it will remain at t is equal to 0 positive. So by using the voltage division rule, we can find out this value. So here the total voltage is 8, and this Vc is the voltage across this 6 kilo ohm. So this is given by 6 kilo ohm divided by sum of both the resistances. So it will be equal to, so 2 kilo ohm and this 6 kilo ohm, they are connected in series, so it will be equal to 8 kilo ohm. Okay, so from here we are getting Vc of 0 negative is 6 volt. It means initially capacitor के across जो voltage है, this is 6 volt. Okay, now we have to find out the I of R at t is equal to 0 positive. So at a particular instant, that is at t is equal to 0 positive, I have already told you that for a particular instant, inductor, it will be replaced by current source, and initially जो inductor के through जो current flow हो रहा होगा, that will be the value of that current source. Okay, and the direction will also remain same. Similarly, at t is equal to 0 positive, that is at a particular instant, this capacitor, it will be replaced by voltage source. So capacitor is replaced by a voltage source, and the value of this voltage source, it will be equal to Vc of 0 negative, because capacitor, it will not allow the sudden change. Okay, so Vc जो है at t is equal to 0 positive, it will be equal to Vc of 0 negative, which is equal to 6 volt, and you have to take that polarity. Okay, upward जो terminal है, that is plus, and below terminal is minus, so it will be equal to 6 volt. Okay, also at t is equal to 0 positive, so this is after t is equal to 0. So t is equal to 0 पे हमारा जो switch है, it is getting open. Okay, so switch is getting open at t is equal to 0 positive. So just after the 0 instant, our switch will be open. Okay, so the switch is also open at this instant. Okay, so let us draw the circuit. Then here we are having a 8 volt voltage source. Okay, so this is 8 volt voltage source. Then this switch, now it will become open circuit. Okay, this is 2 kilo ohm, so this is 2 kilo ohm resistance. Now the switch will become open circuited. Okay, now here we are having a capacitor. Now it will be replaced by the voltage source. Okay, so the capacitor tha, it was initially charged to 6 volt. Now this is connected in parallel with the resistance of 6 kilo ohm, and the current flowing through this, it is given by I of R. So we have drawn the circuit at t is equal to 0 positive. So the current which is flowing through this resistance is, it is given by IR of 0 positive. So its value is given by IR of 0 positive, it is given by V by R. So this 6 volt, it will be appearing across this 6 kilo ohm. So this is given by 6 by 6 kilo ohm. So we are getting the value of IR of 0 positive as 1 milliampere. Okay, so 1 milliampere is option A is correct. Okay, सो वीडियो आपको अच्छी लग रही है तो प्लीज़ वीडियो को लाइक करें, एंड आप अपने फ्रेंड्स के साथ शेयर भी कर सकते हैं. इफ़ यू आर वॉचिंग आवर चैनल फॉर द फर्स्ट टाइम, प्लीज़ डू सब्सक्राइब. ओके, सो लेट अस सी नेक्स्ट क्वेश्चन. Two voltage sources have been in the following circuit for a long time. Okay, it means both the sources are present for a long time. It means the circuit is under the steady state. Now we have to find out the IL of t for the t greater than 0. So this circuit is consisting of two voltage source. Okay, so एक है 72 volt and next voltage source is 36 into u of minus of t. So let us draw the waveform for this voltage source. So I have already told, so u of minus t is indicating that is folding about y axis. So it means it is present from minus infinity to t is equal to 0 instant. Okay, so and the value of this voltage source, it is 36 volt, and it is present from t is equal to minus infinity से लेके 0 तक present है, and it is given by 36 into u of minus t, that is folding about y axis. Okay, and the 72 volt voltage source, it is present for all the instant of time. It means for the t less than 0, t greater than 0, means minus infinity से लेके plus infinity तक this voltage source it will be present. Okay, so in this voltage source at t is equal to 0, the value of the voltage source is changing suddenly from the 36 volt to 0 volt. It means at this instant the transient will occur. It means यहाँ पे t is equal to 0 पे we can say that switching is occurring. So let us draw the circuit for t is equal to 0 negative. Okay, so if we draw at t is equal to 0 negative, already given in the question that the circuit is under the steady state, and under the steady state the inductor it will become short circuit. Okay, now if we talk about the voltage source, so for the t is equal to 0 negative, the value of this voltage source is 36 volt and this is 72 volt. Okay, it means both the voltage source are present in the circuit. So let me draw. So this is 60 ohm. Okay, and this voltage source is 36 volt for the t less than 0, and this is 120 ohm. So यहाँ पे क्या है, this is 72 volt voltage source. Okay, this is also present in the circuit. Now this is 120 ohm. Now under the steady state this inductor it will become short circuit. Okay, so the current which is flowing is suppose I of L. Okay, at t is equal to 0 negative. So we have to find out the value of this. Okay, so we can solve this circuit using the nodal analysis. So this circuit is having the two node, जिसमें से हम एक node को reference node ले लेंगे and this is another node. Suppose the potential at this node is V1. Okay, so in order to apply the nodal analysis, first we have to mark the current in the outward direction. Okay, so we can apply the nodal analysis at this node at which the potential is V1. Okay, so sum of incoming current is equal to sum of outgoing current. तो हमने क्या है, सारे outgoing currents को mark किया है. It means sum of outgoing current it will be equal to 0. So now what is the value of this current? It is given by V1 minus of V1 minus 36. Okay, because this voltage source it will give the current in this direction which will be opposing this current. Okay, so V1 minus 36 by 60, then V1 minus of 72 by resistance value is 120, then the value of this current it is given by V1 by 120, it is equal to 0. So if we take the LCM as 120, so we are getting 2v1, this will be equal to minus of 72 plus v1 minus 72 plus v1, this is equal to 0. So this is 4v1, it is equal to this is 144. So from V1, here we are getting V1 as 144 by 4, which is equal to 36 volt. Okay, so now V1 हमें मिल गया, then we can easily find the value of this IL0 negative. So it means, so the value of this IL, that is current flowing through the inductor at t is equal to 0 negative, it will be given by IL of 0, it will be equal to IL of 0 positive. So the value of this current, it will be given by V1 by 120. So V1 value is 36 by 120, so this will be equal to 0.3 ampere. Okay, so now we have calculated the initial current which is flowing through this inductor, which is 0.3 ampere. Okay, next we have to find out the IL of t for the t greater than 0. Okay, so let us draw the circuit for the t greater than 0. So now if we draw the circuit for the t greater than 0, तो 72 volt जो voltage source है, it will be present for the t greater than 0, but this 36 into u of minus t, it is becoming 0. Okay, so 0 volt, it means, so this 36 into u of minus of t, this will be equal to 0 volt for the t greater than 0, and 0 volt, this will indicate that this voltage source is getting short circuited for the t greater than 0. It means it will become short circuit and this voltage source will remain as it is. Okay, so let us draw the circuit for the t greater than 0. Okay, so यहाँ पे हमारे पास था एक 60 ohm resistance. Okay, and this 36 into u of t, as voltage source has become 0, तो अगर voltage source की value 0 होती है, then it is replaced by short circuit. This is 120 ohm and this is 72 volt, it will remain as it is. Okay, so this is 72 volt and this is connected in parallel with, so this is also 120 ohm and this is inductor value is 0.2 Henry. Okay, so inductor value is 0.2 Henry. Okay, so now this is RL circuit. So this is RL circuit with DC source. Okay, so I have told you the formula in order to find out the current expression. Okay, so IL of t, if you have to find out this current expression, it is simply given by the formula that IL of t, it is given by I of infinity plus I of 0 positive minus I of infinity into e to the power minus t by tau. So I of infinity is the current flowing through this inductor under the steady state condition. Okay, and I of 0 positive we have already calculated as this, it is 0.3 ampere. So the value of I of 0 positive is 0.3 ampere. Suppose this is equation 1. So this equation was only valid for the DC source and step input, and this network is containing DC source, so we can use this formula. Okay, so now let us find out the value of I of infinity. Okay, so for that, let us draw the circuit at t is equal to infinity. That is, t is equal to infinity, it means that is circuit is under the steady state. So if the circuit is under the steady state, then this inductor, it will become short circuit. Okay, so let us draw the circuit. So this is 60 ohm. Okay, and it is connected in parallel with, this is 120 ohm and this is 72 volt voltage source. Okay, this is 72 volt and this is 120 ohm. Now under the steady state, this inductor, it will become short circuit. Okay, then the current flowing through the inductor, it will be given by I of infinity, and we have to find out the value of this I of infinity. Okay, so again we can solve this using the nodal analysis. Suppose this is reference node and the potential at this point is given by, suppose V, then you have to mark the current in the outward direction. Okay, then we have to find out the value of this V. So this is given by V by 60 plus V minus of 72 by 120 plus V by 120 is equal to 0. So by taking the LCM as 120, we are getting V voltage as 18 volt after the simplification. Okay, so if V we are getting as 18 volt, then we can easily find the I of infinity value. So I of infinity, it will be given by V voltage by 120, that is 18 by 120, it will be equal to 0.15 ampere. Okay, so let me write again, that is I of infinity, it will be given by V voltage by 120. So V voltage we have calculated as 18 volt by 120, so it is getting 0.15 ampere. Okay, so I of infinity, we are getting this value is 0.15 ampere. Now we are only left with this tau, so it means we have to calculate tau, that is time constant, and this is RL circuit. So for the RL circuit, time constant is given by L by R. So this is consisting of multiple resistances, so you have to find out R equivalent. Okay, so let us find out the time constant which is given by L by R equivalent. Okay, so यहाँ पे क्या है, सिंगल इंडक्टर है, and the value of the inductor is 0.2 Henry. Okay, so this is given by 0.2. We have to calculate R equivalent. Okay, so R equivalent calculate करने के लिए we have to deactivate the circuit. Okay, and we have to calculate R equivalent across the inductor terminal. So if we deactivate this circuit, then this voltage source, it will become short circuit, and we have to find out across this inductor terminal. So the circuit will become, so यहाँ पे क्या है, 60 ohm resistance है. Okay, so this is 60 ohm and it is connected in parallel with 120 ohm. So when we deactivate the circuit, the voltage source, it will be replaced by short circuit. Okay, and this is connected, this is 120 ohm, and now we have to find out R equivalent across the inductor terminal. So it means you have to open the inductor. So from here we have to find out R equivalent. So it means from here it is visible that the 60 ohm and 120 ohm, it is connected in parallel. So if we simplify its R equivalent, it will be given by R1 into R2, that is 60 into 120 divided by sum of both the resistances. So it will be equal to 180. So this is, we are getting 40 ohm. So now this 40 ohm, it will be connected in series with this 120 ohm, so that is 40 plus 120. So R equivalent we are getting as 160 ohm. So if we put here, that is 0.2 by 160, then we are getting as 1.25 into 10 to the power minus 3 second. Okay, so this is the time constant. We have find out all the values. So let us substitute in the formula. So let us substitute all the values. So substitute all the values in equation 1. Okay, so equation 1 is this. Okay, so this is IL of t is equal to, so IL of t, it is given by I of infinity plus I of 0 positive minus I of infinity into e to the power minus t by tau. Okay, so I of infinity we have calculated as 0.15 plus I of 0 positive we have calculated as, this is 0.3. Okay, so 0.3 minus 0.15 into e to the power minus t, time constant just now we have calculated as 1.25 into 10 to the power minus of 3. Okay, so if we simplify this, we are getting 0.15, so it will be equal to again 0.15 into e to the power minus, this is 1.25. So this 10 to the power minus 3, when it will go in the numerator, it will be equal to plus 10 to the power 3. Okay, so we are getting the IL of t expression as 0.15 plus 0.15 into e to the power, this will be equal to minus of 800. Okay, 800 into t. Okay, so this is the answer for this question, and this is matching with the option 0.15 plus 0.15 into e to the power minus 800t, that is option D is correct. Okay, now let us see the last question. So question is, in the following circuit, the switch is closed at t is equal to 0 with the capacitors uncharged. It means this switch is getting closed at t is equal to 0. It means for the t less than 0 switch क्या है, open था, and जो capacitor था वो uncharged था. It means initially the voltage across the capacitor, it will be equal to 0 volt, already given in the question. Okay, we have to find out the value of d of ic by dt and d square ic by dt square at t is equal to 0 positive. It means सबसे पहले क्या है कि we have to find out the current flowing through the capacitor, that is ic of t expression, which is given by dc into, so current through capacitor, it is given by c into dv by dt. Okay, so dvc t by dt. So यहाँ से क्या है कि हम ic of t का एक्सप्रेशन फाइंड आउट करेंगे, देन वी विल डिफरेंशिएट दिस इक्वेशन विद रिस्पेक्ट टू t, तो हमें मिलेगा dic by dt, एंड देन अगेन डिफरेंशिएट करेंगे, देन वी विल बी गेटिंग d square ic by dt square at t is equal to 0 positive. Okay, so let us first solve for t is equal to 0 negative. Okay, so सबसे पहले क्या है, t is equal to 0 negative है, already given है कि जो switch है it was open. Okay, so if the switch is open then no current is flowing and initially the capacitor is uncharged. It means vc of 0 negative it will be equal to vc of 0 positive. तो अगर capacitor initially uncharged है, it means there is no voltage across the capacitor. So now if we draw the circuit for the t greater than 0, so this is the circuit for the t greater than 0. Now the switch it will be closed. Okay, so here we are having 100 volt voltage source. Okay, this is 1 kilo ohm. Now the switch it will be closed, and here we are having a capacitor. Value of this capacitor is 1 microfarad. Okay, so suppose the voltage across this capacitor is vc. Okay, so we have to find out this voltage across the capacitor. So this is rc circuit with the dc source. Okay, so this is rc circuit with the dc source, so we know the expression to find out vc of t. Okay, then it will be given by, so the voltage across the capacitor is given by Vc of infinity plus Vc of 0 positive minus Vc of infinity into e to the power minus t by tau. So this equation was only valid when the circuit consists of DC source, and यहाँ पे DC source है, it means we can use this relation. Okay, so we have to find out Vc of infinity. It means we have to find out the voltage across this capacitor under the steady state. So under the steady state this capacitor will become open circuit, that is at t is equal to infinity. Here we are having this 100 volt voltage source, this is 1 kilo ohm, and under the steady state this capacitor it will become open circuit. Then what is the value of Vc of infinity? It will be simply equal to 100 volt. Okay, so it means Vc of infinity we are getting 100 volt, and initially the capacitor was uncharged, so the voltage is 0, and again Vc of infinity is 100, then e to the power. So next we have to find out the time constant. Okay, the time constant, this is RC circuit, single resistance and single capacitance is present, so time constant is given by R into C. So resistance value is 1 kilo ohm, that is 10 to the power 3, and capacitance value is 1 microfarad, that is 10 to the power minus 6. So time constant we are getting as 10 to the power minus 3 second. Okay, so if we substitute this value here, we are getting e to the power minus of 1000 into t. So it means the Vc of t, that is voltage across the capacitor, we are getting as 100 minus of 100 into e to the power minus 1000 into t. So suppose this is equation 1. Now let us find out the current flowing through the capacitor. So current flowing through the capacitor, that is IC of t, it is given by C dV by dt. Okay, so we have find out the V of t expression. Okay, and capacitance value given in the question is 1 microfarad. Okay, so it will be equal to 10 to the power minus 6 into d by dt of, let us put Vc of t expression, that is from the equation 1, which is 100 minus of 100 into e to the power minus 1000 t. Okay, so let us put here, so it will be equal to 100 minus of 100 into e to the power minus 1000 into t. Okay, so let us differentiate this equation. Then we are getting, this is 10 to the power minus 6, differentiation of 100 it will be equal to 0, and this is minus of 100 e to the power minus 1000 into t, differentiation of minus 1000 t, it will be equal to minus of 1000. Okay, so if we simplify, minus minus it will become plus, this is 10 की power minus 6, and ये this is 10 की power 3 into 2, that is 10 की power 5. So we are getting 10 to the power minus 1, which is equal to 0.1. Okay, so we are getting as this is 0.1 into e to the power minus 1000 into t. So this is the expression for IC of t. okay. But in the question we have to find out d of ict by dt. It means we have to differentiate this equation, okay, with respect to t. So it will be equal to 0.1 into e to the power minus 1000 into t, and the differentiation of minus 1000 t, it will be equal to minus of 1000. It means we are getting minus of 100 into e to the power minus 1000 into t. So d of ict by dt, so we have to find out at t is equal to 0 positive. It means in place of t we have to put 0. So if we put 0, e to the power 0, it will be equal to 1. So it means d of ic t by dt we are getting as minus of 100 ampere per second, okay, because this is current is ampere, this is ampere per second, okay. So this is current is ampere per second. So this is the first part answer, that is we have find out the value of dic by dt, okay. In the next part we have to find out d square ic by dt square at t is equal to 0 positive. It means again we have to differentiate this equation. Suppose this is equation 2, so we have to differentiate this with respect to t, and then we have to substitute t is equal to 0 positive. So dic by dt expression we are getting as minus of 100 into e to the power minus 1000 t, okay. So d of ict by dt expression we are getting as minus of 100 into e to the power minus 1000 into t. So let us differentiate this again with respect to t. Then we are getting minus of 100 into e to the power minus 1000 into t. Differentiation of minus 1000 into t is minus 1000. So this will be equal to, this is 10 to the power 5 e to the power minus 1000 into t, okay. We have to find out d square ict by dt square at t is equal to 0 positive. So if we substitute t is equal to 0 positive, then e to the power 0, it will be equal to 1. So we are getting 10 to the power 5 into 1, that is 10 to the power 5 ampere per second, okay. So this is the answer, and this is matching with option a, that is minus of 100 and 10 to the power 5 ampere per second. सो आज के लिए इतना ही. नेक्स्ट लेक्चर में हम लोग और ट्रांजिएंट के क्वेश्चंस देखेंगे, बट उसको हम लैपलेस ट्रांसफॉर्म टेक्निक की हेल्प से सॉल्व करेंगे, ओके. सो वीडियो आपको कैसा लगा कमेंट सेक्शन में मुझे ज़रूर बताएं, एंड इफ़ यू हैव एनी क्वेरी डू लेट मी नो इन द कमेंट सेक्शन. आई विल डेफिनेटली आंसर देम, ओके. सो थैंक यू फॉर वॉचिंग.